Hi there, and welcome to this demo session. I'm Jonah Jones. I'm a Container Partner Solutions Architect at Amazon Web Services, and I'm going to be showing you today in a few minutes how you can set up Amazon EKS GitOps with progressive delivery using AppMesh. So yeah, let's jump into it. So today for our demo, we're going to be showing you how to set up GitOps. So I've done a few things ahead of time just to kind of make sure that we can get everything in this demo and kind of save a little bit of time here. But normally, if you're setting up GitOps, you would need to make an EKS cluster. And so you can do that using EKS ETL or any of the other tools. And you would also need a GitHub repository. And the first thing you do when you are making a GitHub repository with GitOps is you need to make an SSH key here. And so when I make this, I'm using it with my email for GitHub. And what I'm going to do is I'm going to take a look at the public key here. I know that was the private key there I just showed you. And we would take that and we would add it to our deploy keys in our GitHub repo we made here. So you can substantiate a new repo, and you would add one, so this would be your workshop SSH key. The next thing we would be doing is we would need to be creating a namespace for Flux. So Flux is the GitOps engine created by Weaveworks. It's an open source project, and it utilizes a few tools to help handle GitOps and progressive delivery. So we're going to create a namespace for Flux, and we're going to add the Flux Helm repo here. And then we would install Flux. So here we're putting it in the Flux namespace. We're making sure to call out our GitHub repo. So I just made this one right beforehand. It's called GitOps Workshop. That's the one where I put the SSH key in. And we're going to set the poll interval really low. So we're setting it to 1 minute just so that we can try to get through this workshop here. But normally you could set this at 5 minutes or 3 minutes or whatever you felt was better for you. And so this is how often it will pull the GitHub repo to look for changes and declaratively apply them to your cluster. Next, we're going to just take a look at the Flux key that's created. So the Flux will create a secret, a Kubernetes secret under the hood, and then we need to take this key and add this to our GitHub repo as well. And so this is going to be helping make sure that things can talk in addition to our SSH key. So here I would do the command to pull the key down. I'm not actually going to show you guys my key. Better luck next time. But this would be the workshop secret here that we're applying. Awesome. Now we're going to apply the Flux Helm operator CRD. And this is just helping make sure that everything can get pulled as well. It's just part of the whole GitOps setup here. So we install this. Also making sure we call out the Git SSH secret name. So this is the Kubernetes secret that was just created and the Helm version we want to use. And we're going to check to make sure our pods are up. Awesome. So we have the Helm operator and the Flux operator. Now we're going to make a directory for some namespaces. And so we're going to be installing the Amazon CloudWatch Container Insights, Prometheus, and FluentD exporter, so we can get some sort of visualization and performance metrics when we deploy this. And then we're going to deploy AppMesh and then a sample app as well here. So here we're going to start with AppMesh. So we're going to create the namespace here. So I am creating a file that is going to substantiate my namespace. And then we're going to apply this just to save some time. If you're using normal GitOps, you could just do a git add, git commit, git push, and the Flux operator using its 1 minute poll interval would pull this and apply automatically for you. We're going to check to make sure we have the AppMesh namespace. We do. We're going to make a directory for our AppMesh objects, and we're going to pull down the AppMesh controller that's made by AWS. And we are going to apply this as well. Awesome. So here, using GitOps, I've created this Kubernetes manifest object. And here is where I would add, commit, and push. And using the magic of GitOps, We can wait a second, and things under the hood are going to pull. So Flux will pull the Git repo using those keys we instantiated, and we should be able to see it in a second here. So I'm going to create the injector object as well. So this is the @mesh injector. So when your namespace has a label, same with Istio, it can automatically inject an envoy sidecar on applications that are adhering to that label. Awesome. So we're going to check our @mesh system, and we can see that we have the controller and the inject running. And we're also going to create the Prometheus object. You can probably see I created some of these ahead of time just to save time, but this is how you would go about this. And so this is the object that's going to provide open telemetry data in Prometheus format to CloudWatch container insights. So we're going to use the same GitOps method of git, add, commit, and push. And now things are syncing from our GitHub repo into the Kubernetes cluster, sorry. Awesome, so we're checking everything is good. And now, since we added our CloudWatch our Amazon @mesh controller, we can actually go and take a look and see that we are getting some @mesh meshes created. And so we can see them from the AWS CLI or from the kubectl git mesh. So it's doing a git mesh on the @mesh CRD object. Awesome. Now we're going to create a namespace for our CloudWatch object. So these are the CloudWatch exporters. They're going to send that telemetry data back up to the cloud so we can get a nice visualization later. We're going to do the git, add, commit, and push as well. We're going to check to make sure the Amazon CloudWatch namespace is there, and we are all set. And we are going to pull from Amazon the CloudWatch Container Insights FluentD agent. And I'm just saving a little time here. I'm doing a search and replace command with cluster name with the name of our EKS cluster, and region name with US West 2. And then we're also going to be pulling an agent that is going to be handling the Prometheus metrics here. And so here, when you pull these objects, normally they would actually, each of them has a namespace on the top of it. And we have two files, and both of them are going to try to create the same exact namespace. So I'm just pointing out here that if you were following along with the demo, you would need to go into the actual file itself, and you need to edit out this namespace like this. And so I did a live curl command here just to show you how it would be done. So we would go and we would pull out this entire namespace like this and save. Awesome. Next, we would do our git add, commit, and push in the sense of GitOps. And so GitOps has a few tenets here while we have a little bit of time. So like the first one is declarative configuration, and that is at the heart of GitOps. So these are the 5 core tenets that Weave has prescribed when it comes to GitOps. So it's all resources are managed through GitOps process that's expressed declaratively. The second one is version control. Obviously, we're using GitHub, GitLab works. So any sort of version source control is your immutable storage for your backend configuration. And these declarative descriptions are what support immutability, versioning, and version history, right? And this goes a lot towards auditing as well. Automated delivery. So delivery of the declarative descriptions from the repository to your runtime environment is fully automated. So that's all done through Flux, right? We have software agents, so our reconcilers deploy and maintain resources described in our declarative configuration. It's a mouthful, but that's basically breaking down that our agents are the things that are reconciling in that 1-minute pull interval and redeploying. And then the last one is that it has a closed loop. So its actions are performed on divergence between the version-controlled declarative configuration and the actual state of the target system. Again, a mouthful, but that's so that if I go and I start manually editing these cube manifests, and I go and I change the node port, or I change a cluster IP to a load balancer type, GitOps is going to basically use its poll interval and it's going to change it back to whatever is in Git, because that's the source of truth here, right? So these are kind of the GitOps tenets or laws that we abide by. And so I figured I'd just go over these while we have a little time here. Get back to the demo. I promise we're going to get into something cool here. So we're going to check our pods from Amazon CloudWatch. We can see that they're all created. So we have the CloudWatch agent, the Prometheus agent, and the FluentD CloudWatch here. Now we're going to create our app namespace. And like we were talking about earlier, the app mesh injector label is on. So this is going to make sure that the app mesh sidecar is attached to the deployments in here. We are going to git add commit and push again. And then we're going to make a directory, and we are going to save some time. So we're going to be using a pre-made app called pod info here. And don't mind the fail commands. Again, these are pre-installed ahead of time, so it's just saying it already has something there. So don't worry about that. We are going to git add commit and push. So now these are pushed from our local up to GitHub. And now we should be able to get pods, and we should be able to see our pod service and namespace for the namespace apps and see that they're up and running, right? In real time, this would actually take about a minute and a half. Again, I'm trying to save time to make sure we can get to the cool stuff in this. So we have pod backend, front end, etc. We're going to check our app mesh components. So app mesh uses virtual services and virtual nodes as well. So we can see we have the virtual node is going to correspond to the pod backend info, and the virtual service is going to correspond to the service here. We're going to check to make sure we have our virtual router up for app mesh. We can see that it's up and running, which is perfect. This is created by the app mesh controller here. And we're going to check our routes here and just make sure our routes are also up. So those should be all the components of app mesh that we need here. So we can see we have a route here, and it's using 100% of the weight to the pod v2 here app. Awesome. So we are going to export our front end name here like this. And so we're just getting the name of our pod, and what we're actually going to do is we're going to pop into our pod, our front end pod, and we're going to loop and hit the back end to see what is actually happening behind the scenes. And so what we would want to do is we would want progressive delivery here. So when GitOps is pulling a new deployment, we wanted to use canary deployment strategy and shift some of the traffic to the new deployment so we can test it out here. So what I'm going to do is I'm going to get the name of it here, and I'm going to exec into the pod here. And from here, I'm going to curl to test to see that I can hit the backend. And I'm getting response back. And so here, we can actually see that it's using a random hash. And so this one is using the v2 as well as the random hash. And so when we looked up here, we can see 100% of our weight is going to v2 apps. So what we're going to do is we're going to do a half-second curl here that's going to loop. And we're going to see that it's continuously hitting the v2. But what we'll do is we will update the mesh routes, and we're going to change the loading to 50%. And what that will do is that will allow us to simulate what it would be like if we were testing a canary deployment. So what I will do here is I'm going to cancel out of this demo. I'm actually going to run these commands here what will happen often in a typical application deployment is when you have V1 of your service or V2 or the old one, you'll have 100% of traffic going there. And so what we're going to do actually is we're going to be editing our virtual service here, and we're going to send 50% of the traffic to our new version. In this case, I'm calling the new one V1, so hopefully it's not too confusing. But what hopefully we'll see is that our loop is going to start sending half the traffic to V1. So if I look down here, I can start to see that it is now alternating between V2 and V1. Right? Again, I've pre-done a few of these things ahead of time just to make sure. But what we'll do is we can push it to Git and push. And it is now pushed to Git. But in the case of a typical application deployment, or a lot of times when people work at software companies, sometimes that first deployment doesn't actually work. So what we're going to actually go off the script a little bit here. And what we will do is we're going to go straight into this apps virtual service. And we're going to show you how you would reset this back. And so what you could do is you could straight up change this. So you could do the roll forward strategy, which is a pretty common strategy. So you could straight up change it back to 100%, and then you could do a git add, git commit, revert changes, and git push, and our GitOps would also sync it. Or you could go straight and do a git reset hard head like this. And so what I will do is we're going to stand here and look at this for a few seconds, and hopefully our Flux will pick up our changes here, and we'll start to see 100% of this go back to V2. So we can actually wait here a second. And while we're waiting here, I think it'd be a good time to go take a look at the Prometheus metrics. So this whole time we installed the CloudWatch Prometheus daemon set for container insights. And so we can actually get some telemetry data about our cluster and the services running in it. So if we go back to our CloudWatch console here, we can take a look at our performance monitoring tab. So you get there by going to Container Insights, Performance Monitoring, and change this to EKS Prometheus App Mesh. And you can actually see the pods we have. So we're running the 2 backend pods and the 1 front-end pod, and your requests per second, and a whole lot of other metrics. So like your inbound traffic, your average uptime, and you can get a graphical representation of how all your data is going, as well as a breakdown of the pods and the traffic by pod here. And so this is a nice advantage that AppMesh automatically is collecting that telemetry data for us. And so if we use the Prometheus daemon set, we can get that to pull and send and get some feature-rich data here. And so now we go back to our deployment, and we can see this curl loop is still running here. And we are now only getting V2 because we had a bad deployment. We roll forward, push all the data back to V2 on the virtual service, and now it's sending 100% of the traffic back. So we can see our loop is running here, but it is only sending to V2 here. And you can tell it's running because I keep having to scroll down every time I scroll back up because it's running so fast. So yeah, so this was a demo about how we can use GitOps and AppMesh to do some progressive delivery and to our cluster. And hopefully you learned a thing or two. I will post the GitHub repo and the talk abstract, and hopefully you guys can follow along and try it out yourselves. And it's been a pleasure walking you through how to use GitOps with EKS and AppMesh and do progressive application delivery. And if you want to learn more, please check out the AWS booth where we have members. They can talk to you and case studies and blog posts. And also check out the repo and the talk abstract if you want to try this yourself. And thank you so much for watching.